Hey everyone, thanks for coming out. Like I say always, today we're doing some chemical attacks for national security. Now, as I focus on national security and real research, this is where the real research comes in. We can talk about lethal concentration and chemical and biological attacks, etc. But how do we prepare for these? How do we know they're even lethal? Well, as you read in the article on national security, they use rats. Now, as you saw other videos with our studio, we have to input the data set. Right here, we import it. There's that reader package I mentioned to you earlier about that you have to actually download this one. It just does it automatically when you input something. So as you can see, we have only 14 pieces of data. It's not like the Trump data, which is Trump tweets, which is 20,761. You're probably not going to kill that many mice. But I apologize to the people in PETA, but this is how you do real research, unfortunately. With mice, you essentially, give them a dose of this lethal um, concentration. Oh, I think I spelled that wrong. And you see, the extent to which it kills the rats. Now they use rats because we have a similar biological makeup. I don't think you'll be getting a rat's heart anytime soon when you need it, but they do test rats on radiation, chemicals, toxicity, etc. So this is very important actually for national security to understand the extent to which these are lethal concentrations. So what we're going to do here is quickly, we attach the data set. And what we're going to see is what these poor mice, I do say poor mice, are doing. So as we can see, there's a dose of the toxicity, and then the survival rate, that could be times of minutes, hours. I mean, I don't know. Hopefully it's hours or days, because you wouldn't want something to kill you that quickly. But this is very, very important for national security to measure it. And it's also important for all you someday lawyers out there. You also can use this for your cases. Like, let's say, for example, someone was given too much radiation, a cancer patient, and they try to sue the hospital. If there is a positive, well, that is now negative, correlation that's statistically significant between dose and survival, then you could basically show, look at, you gave so much radiation to my abuela or babushka, a grandmother, that she died, and you shouldn't have given that much dosage. Same thing goes if someone has cancer and they were exposed to, say, radiation and high tension wires when they grew up, or things like that. You can use these types of things, this types of data and models in your law cases. So let's run it. What are we going to call this? Poor mice, because it's done on mice, rats. Is there a different? Poor rats. I think they are rats. Um, and you use the LM function. This is all quantitative variables, right? Both the dose and the survival. The independent variable, the cause, is actually the dose, and the dependent variable, the effect, is survival. So what we're going to do is we're going to do the survival is the dependent variable, so that comes first. Then dose. See, it's pretty easy once you get the hang of it. And then data equals, the name of the data set is, as we see, survival right there. See, you see the data set here. Hit that. Boom. Now we got poor rats. Oh, the poor rats. So now we do poor. See, they're having a party, the rats, not for too long because they're going to be killed. So we're seeing, okay, is there significant correlation? So you see here, for every dose of this toxicity, right? Let's say it's a sarin gas attack, which You read about Aum Shinrikyo, right? For every dose, you're surviving 0.027. Well, I'd say 0.028 because to round it off, survival time less, whatever time that is, minutes, hours, days, etc. And then you see a pretty good t-value, anything over 2, which means it's moving away from 0. And that's a negative number, so you know it's negative, and that's a strong p-value. It's not the scientific notation like in others. There's only 2 stars, but it doesn't matter. To get below 0.05 is difficult anyways, right? So you really want to say to yourself, this is statistically significant, meaning if you are a real scientist and doing real research in national security and you're doing research on the toxicity, is that the word, toxicity? Then you're basically, home free. You can say, look at these chemical weapons are extremely, extremely dangerous, which is good if we're using them, bad if we're on the losing side. So you have to ask yourself, right? To what extent these chemical weapons are toxic and deadly and lethal, and what lethal concentration. And that's what they use of the rats. And this is exactly what they do. I mean, this is the doses, just the survival, etc. Not the best multiple R squared here. It's still statistically significant, but why? There's probably a lot of variance when it's going down. So let's use ggplot to graph this, because as we know, ggplot generates the best and most beautiful visualization. So the data itself is survival. We just add aesthetics, which is what it is. It's X equals dose and Y equals survival. It's only survival. And let's take a look. Then you have GM. We're doing GM points still. The next one will not be geo point. And then stat smooth. That is the best fitting line. It's called the OLS model. Oops. And smooth. Its method equals LM. And then no, that ugly gray area. I can show you what it looks like without it, so I'll do that. Now, GM points, what color do we like the points? We like ooh. I don't think I've ever used beige because I don't know how to spell it. And I don't think I do know how to spell beige. There it is, beige. I've never used that color. And then for the line, we'll use, how about magenta. Oh man, I'm not doing well here. Nope. What is it here? I'll just use green. I'm like, well, I can't even spell green. Long day today. All right, so let's do it. So as you can see, with all my points, beige does not look good. So let's make them red because you can't really see them. So as you can see, the reason why I'll bring up the models right here. The reason why the multiple R squared is not the best, even though it's considered statistically significant, is you can see why it's significant, because there's a downward trend. The more dose you get, right? So you see the survival decreases, but look at how the data points are surrounding the line. They're not close to the line as you would see. That's why if you look, the residual standard error as well is 13, and that measures how far these are away from the line. So it would be a better fitting model if they were closer to the line, but that's that's kind of the fantasy world, right? We live in the real world, and nothing is going to be perfectly around this line, except for, of course, the perfect Donald Trump tweets. So, as you can see, it is a downward trend. It is negative. It is significant. So, we can say with certainty, with a high confidence rate, that's what the p value is telling us, that there is a relationship, a negative relationship in this case, between the dosage you get of the toxicity and then the survival rate of these poor rats. And this is very important for national security because this is how they measure. If this is the sarin, say, for example, like the sarin gas attack of Tokyo in 1994, you kind of learn through this real research how to deal with it, how long these people have to survive, relatively speaking, of course. I mean, we aren't mice or rats, but it does give us a good idea of how long you might take to, I'm kind of stuttering over my words because I don't want to say it, but die if you get hit with these um this toxin. So, and here we see I just did ggplotly, which makes it interactive. So that's pretty cool in a way. I mean, not cool in a chemical attack, but that you can actually measure the extent to which this has a lethal concentration. And then not only do we have the real research here, the numbers themselves, right, that show it's statistically significant, we can actually generate pretty cool visualizations. And you can hit the zoom button and it'll zoom it up. I can do a new share in order to do this one. There it goes, and I'll make it big. And then you can basically see it. So it's pretty cool. And what Plotly is extension of ggplot. You know, you can lasso this stuff. Look at that. You know, oh, I'm talking about this or here, etc. So pretty good research. This is what real research is in national security, is using these numbers. And our next theme is going to be on terrorism and whether or not terrorism is decreasing or increasing, not only throughout the United States, but the world. Take care, everyone.